Hello, everyone. Welcome to Chemistry with Professor John. All right, we continue the discussions with alkene. This is reaction of alkene. Well, this part is actually a summary of what we can do with alkenes. And then on the next video, we're going to go over the details about mechanisms and stuff. Okay. All right. Alkene. There's many reactions we can carry out with alkenes. So take a look at this. Alkenes. We can do. We can make. Let's start with the top one. Okay. We can make an alcohol, and that would be. You can see the reagents here. We can do hydrations, just simply adding water to alkene. Water, H plus, and that will be Markovnikov. Okay. You can also do water, mercury acetate, and then sodium borohydride to remove the mercury. Okay, so that will give us Markovnikov products, meaning OH to the more substituted carbon. Okay, that's Markovnikov. Okay, if you do anti-Markovnikov with this set of reagents, the hydroborations, anti-Markovnikov, you got OH onto the less substituted carbon, so there's a difference there. All right. Okay, moving towards the right, we got hydrogenations, adding hydrogen to alkene, you get alkanes. Very simple. If we do osmium tetroxide as a catalyst, and there's some other supporting reagent as well. We're going to see that in a quick review. Okay, I forgot it right now, but we'll look at it. So with OSO4, the main reagents, we'll get diol. Okay, and that should be on the same. If it's like a ring system, it'll be on the same side. So if you have like a cyclohexene and you do OSO4, I want to say it's hydrogen peroxide on the second step, something like that. OSO4. Oh, here we go. OSO4 and then aqueous, sodium hydrogen sulfite or bisulfite. Okay, so you get OH and OH on the same side. Okay, dihydroxylations, making a diol. Now you will get OH on the same side. Now that would be, I want to say plus enantiomer. So this should be, I'm trying to think, it's RRSS. So this would be 1, 2, 3. So that should be R. And the second one is, oh, this is RS. So so it's meso. One R and one S. Yeah, it makes sense because this molecule has an internal plan of symmetry. So this is meso compound, meaning you got two chiral carbon, but the molecule overall is not chiral. Okay, so that's the products. All right. Now, if you do a propanations, you do CH2I2 zinc and copper alloy, you get the cyclopropane ring. Okay. If you use MCPBA, that's metachloropurbenzoic acid. That's a very popular epoxidation reagent. You get epoxide. Okay. We can also add chlorine water. So notice hydroxy go into the more substituted carbon. That's um, that's like Markovnikov. Okay. And you can mismatch them. One got the chlorine, the other one's got the OH. Also work with bromine or iodide. All right. The but chlorine water is the most popular one. Or symmetrical additions. Simply just use chlorine and in carbon tetrachloride, that's the solvent. So you get the 2 chlorine in, and it should be in the next part. We're going to talk about the stereochemistry. It should be opposite, okay, or anti. We can also add XBr or HCl or HI Markovnikov. So the Br will go into the more substituted carbon. A couple more, okay. Oxidative cleavage, meaning we can use ozone to cut the double bond and to split the double bond into 2 molecules, and then you stick 1 oxygen on each side of the double bonds right here. Okay. All right, and then finally, similar to adding water, this time we're adding alcohol, so we get the ether instead of OH, and it's Markovnikov. All right, so about stereochemistry. Now, when you add chlorine, you see 2 chlorine. It's not, this one it doesn't matter, but if you have something like a cyclic alkene, you will get the 2 bromine coming in. Trans. It's not like OSO4. OSO4, remember, is cis. Right here, this one is cis. That's for OSO4, but this one is bromination is trans. Chlorination is also trans. So the 2 chlorine add in opposite directions. Okay. I mean, opposite size. Similarly, we got right here and there. Okay. Okay, here's more to go. For this, it doesn't matter. Okay. We got the hydroboration again, MCPBA, dihydroxylations. Okay, and bromination, HBr, ozone, oxymercuration. So those are repeats of. This is a very good table, summarizing all the reactions, like hydrohalogenation, like HX, okay, H and halogens. And it tell you what we adding, okay. X go into the more substituted carbon, and it tell you the stereochemistry on the same side and opposite side. Now, free radical, it's gonna be here's a condition. It's gonna be anti-Markovnikov. Okay, that's anti-Markovnikov, and it go same and opposite side. If you do water, that's H and OH. and that's Markovnikov. OH going to the more substituted carbon. Same and opposite side. You do mercury acetate, same thing. It's just minimizing the rearrangements. Also Markovnikov, same and opposite side. So you got two products there, same and opposite sides. But halohydrations, OH on a more substituted, and they have to be opposite. Hydroborations, you're also adding hydrogen and OH. It's anti-Markovnikov. I'm going to circle the anti-Markovnikov, and that will be OH on a less substituted carbon, and they go on the same side. All right. So if you get a like that, it will be anti-Markovnikov. So the hydrogen will go here, and the OH this is anti-Markovnikov, so the hydrogen will go there and the OH will go there on the same side. Okay, this is a BH3. If you just simply add halogen, it's going to go opposite side. If you do dihydroxylations, it's going to go same side as you see above, and then you add the two hydrogens, meaning hydrogen molecule, they go on the same side because of the catalysts hold them on the same side. Cool. All right, so that's a quick summary of all the reaction of alkenes, and then on the next video we're gonna go over more details about mechanisms and step and all that stuff. All right, thank you guys for watching, and see you in the next video.